For problem number 77, we can see we have the number e, and what I said earlier in the first video actually was that e is a number, and I just want to review that really quickly, that e is a number just like pi. It's an irrational number because the decimals don't repeat, and so we get 2.718 is our best approximation to 3 digits for the number e, and it's the natural exponential function, and it happens to fit right in between 2 to the x and 3 to the x because e fits between 2 and 3. And so you could see e on a number line, you could see e to the x on a graph. It has the same x-intercept as the other two functions, 2 to the x and 3 to the x. And so it's really nothing, you won't treat e to any power any differently than you would treat a 3 to that power or 2 to the power. So let's go ahead and see how it changes. Like I said, it's not really going to change anything other than it's just a different number. And even though it looks like it's represented by a letter, but it means a number. The letter x is represented by a letter, and it means a variable. So it's totally different. X is a variable, e is a constant. So I just want to make sure you keep that in mind. Well, if you have been paying attention and following along, you realize that there's been a common theme to every single one of these problems from number 61 all the way through number 77 here. And that is that we can express both the left and the right sides of our equations as some number to a power. And in this case, number 77, the number happens to be e. E is the same as e, so therefore, since the bases are the same, we have the exponents also are the same. So I'm going to go ahead and just equate the exponents again. If the bases are equal, the exponents have to be equal. And I like to keep my variables positive. So I'm going to subtract x from both sides, and I'm also going to subtract 8 from both sides. And therefore I get 2x equals negative 8, and if I divided both sides by 2, I would get x equals negative 4. So that's what I'm going to do. Divide both sides by 2, x equals negative 4, and if that were if the e were replaced with a 3, we'd have the same exact steps. If the e were replaced by any other constant, we'd have the same exact steps. So don't be scared of that e. It's not anything to be afraid of. Number 79, we have e to the x squared. And on the right side, we have e to the 3x. Multiply that by 1 over e squared. Okay. So this is a good problem because the first thing we realize is that every single one of the terms that we see here is e to some power. Now, this guy here is the same. This guy here is the same. But what do we do with this? Well, if you think about it, 1 over 3 squared is 3 to the negative 2. 1 over 2 squared is 2 to the negative 2. Therefore, it would make sense that 1 over e squared would be e to the negative 2. And that's exactly what it is. And as we said in the last video, one of the last couple problems, we can't do anything yet here. We can't equate the exponents yet until we get 1 base to 1 power on the left equals 1 base to 1 power on the right. And remember, the property of exponents says that if we multiply the same base, we add the exponents. So we have 3x plus negative 2 or 3x minus 2. And then again, the bases are the same. E is the same as e. Therefore, the exponents have to be the same. We get x squared equals 3x minus 2. And then now we get another quadratic equation, and we're going to go ahead and gather all the terms to one side. We're going to subtract 3x from both sides. We're going to add 2 to both sides. And then, since we have a quadratic equation that can be factored on the left side, we're going to go ahead and factor it. X and x, new factors of 2 that have a sum of negative 3. That's negative 2 and negative 1. And therefore, x equals 1 and x equals 2 because we set each factor equal to 0. So we have the set of numbers, 1 and 2, that make the original equation true. Okay, that rhymed.